Okay, hey everyone, I'm Tom. Like Chris mentioned, I was an intern at SideFX. Now I work there. Today, I'm going to be presenting about Apex. This title is pretty vague, so we have another one, which is, can I use Apex for anything other than rigs? We've talked about Apex a lot in the animation context, so I thought I'd do a presentation that kind of goes over what you can do besides animation. So a little bit about myself, because I've been told I need to do this. I'm Tom. I like Linux. I work at SideFX. I have many keyboards for no particular reason. I just like them. And then I've been told that's not enough to say. So my day-to-day looks like this. I basically bash my head against the keyboard and try and do stuff for the character team, but also for the Copernicus team, and then miscellaneous stuff here and there. So let's get into it. Little disclaimer first. At the top there is the node shapes we ship with Houdini. At the bottom there is a bunch of custom nodes that my friend Ferry Taswin, that you can see his ads on socials, made. So I used them because they look nice. There's also a bunch of jokes everywhere on the slides. At the bottom there, hopefully the people at the back can see them too. So that's the disclaimer. And then HDAs, let's talk about them a little bit, because most of what I do is actually build HDAs. So here's a bunch of tools that I made before I actually was at SideFX. If you want to see them or whatever, you can always ask me for them. I can give them to you. They're all free for everyone to use. They were just fun projects that I made on the side. But I like making HDAs. If you don't know what an HDA is, it basically packages a bunch of nodes into one main node. So you can see there's the RBD material fracture, which is the node on the right there. And it basically just takes the geometry, fractures it. And then on the left there, you can see the whole network that's inside of the node. But that's scary, so we wrap it up, and you can just fracture stuff without having to think about all the hard stuff that you need to do, although it's still very simple, but you know. So when you build HDAs, usually you have this kind of panel here with a bunch of sliders. Let me stop the video here. So you have a bunch of sliders there, and sliders are such a drag, and so they're not fun to play with. They're kind of fun, but we can make it more fun. And a lot of what I try and do is make tools that people like to use. And so I was like, how can I make that happen? I want people to be able to do stuff inside the viewport instead of just dragging sliders around. That's not as fun as pulling vertices with like handles and gizmos and whatnot. So we go into viewer states. If you don't know what a viewer state is, basically inside Houdini, you can jump inside the viewport. Some nodes have these viewer states, which is a bunch of Python code that basically generates these little shapes that I'm dragging onto here in the video. And basically, they just update the parameters automatically over here. And that lets you do stuff interactively in the viewport. Super fun, much more fun than dragging sliders around. So I was like, OK, how do I build this without having to go through all the necessary steps? Well, I can use something that already exists and use that for my own benefit. So we have this tool called rig pose, which is used in animation to actually pose your character. So here I have the capybara skeleton, and I'm posing it. And it's fun because I have handles. It's all within the viewport. I don't have to have my parameters even showing. I just pose the character, and we're having so much fun. So what I did was I was like, well, I have this camera frustum color, like basically anything that's outside of the camera view, I just delete. Optimization is cool. So I was like, how can I make this more fun for everyone to use? So I reused the rig pose state. And if you see in the video here, so now when I enter the viewer state, it's still a rig pose state, but I used it to my advantage. So now I can drag points around, and it automatically updates this frustum. And so I can call the geometry based on that. But without having to touch any parameters or anything, I just stay within the viewports and have the most fun in the world. If you want to look at what's inside, it's an HDA that wraps up these few nodes, and it's basically taking a camera and a box and creating the camera frustum out of that box. And then I just create a skeleton, because that's what we need for the rig pose to work. And then I can reuse the rig pose with that skeleton to drive the frustum. and then the compiled block in there just basically does the deletion, but that's not necessary for the view state to work. So then you're like, oh, well, you're like, this is about apex. There's no apex. This is boring, blah, blah, blah. We want the apex, so here it goes. This is a little primer, because Apex is relatively new. Maybe some of you have never used it. So I came up with a little analogy that hopefully explains what it does. So we can compare it to cooking, where I have a recipe, which is going to be my Apex graph. I have a bunch of ingredients. That's what eggs, flour. That's where you give the recipe to even like make a cake or something. And then we have the chef, which is this Apex invoke. So the graph basically is these points that you can basically create nodes in what we call the Apex network view, which sort of looks like the default network that you would have in Houdini. But basically, this is just a representation for points and geometry that you find here. And to illustrate that point, if you see in this video here, as I drag these nodes around, it just drags this geometry in the viewport, because your Apex graph is just a bunch of geometry with a bunch of attributes, and that's all there is to it. But then once you give that to the chef, it actually produces the result you want. So in this small example, all I'm doing is getting my input, subdividing it, and then outputting that. So if you love scripting, hopefully that's some of you, you can write all of that with Apex script, which is something that was built on top of Python to make it easier to generate Apex graphs. Most of the work that went into this was done by Esther, who's sitting at the back there. I don't want to call it shout out. And so basically, you can also use Python to do this, but Apex script just makes it so much easier. And if you're into scripting, it's much more fun than just putting nodes down. It's kind of Vex versus Vops. Anyways, ingredients are going to be attributes or geometry. So in my case here, I've just promoted two parameters. One of them is my geometry, and one of them is iterations. That's going to be how many times I want to subdivide, because my graph just basically does a subdivision, right? So here I'm just doing one iteration. That's the parameter we promote. And then the way I set those parameters is basically creating this dictionary with this key called iterations. And for the other one, I just plug in some geometry, and that then gets passed to the graph and then outputs. So the chef, the Apex invoke, is basically just going to take all of that. Here's the custom nodes, and basically give me the outputs. So I have my graph, which is this guy, and then I have my two ingredients over here, and then the chef is just going to run the graph with the ingredients and give me the outputs. So in this case, I just plugged in the rubber toy that we all know and love, and subdivided it just the one time. It's very simple, but it's just to kind of show you how it works. Hopefully it clears up some of the questions you may have had. Just a little throwback, I guess. We used to have something called, we still do have it, the precursor to Apex, which was invoke compiled graph, which was basically the same principle. Just the way you would make the graph was like putting stuff in a compile block. The docs call this node very esoteric, which is pretty fun. And then how does that tie in with like the whole concept of I want to make my HDA more fun to play with, more interactive? This is where the animate state comes in. So in this example, this controller that I'm rotating around just drives how many iterations I'm doing on the subdivision algorithm for my box. So I start with a box, and as I rotate this control, it basically gives me a sphere because it's being subdivided. And so this is done because this scene animate is going to be our new chef, and that new chef lets you do things interactively. So how does that work, you're wondering, because I just threw all that out there. Basically, all we had to do here was put down this transform object, which is going to spawn a controller in the viewport. That's what the Apex scene animate does. And so for every one of these that you promote here by wiring it into this palms node, you'll get a controller, and then you can use the values from those controller, like the translate or the rotate or the scale, to drive anything you want. So in my case, I'm just doing subdivision. So what happens is the scene animate needs some kind of special package for it to work properly, because it needs to know what your inputs are, what your graph is, and what your parameters are. So that's when this pack folder sub comes in, where you give it your graph, which is this node here, and the box, which is going to be our inputs. We pack them neatly into this base.rig and base.shape. That's probably too small to read. And then in the graph here, we have this base.shape, and that's how we say our box is going to be our input. So then all we have is this. We pack it, we plug it into this scene animate node, and then it spawns our controller, and it just invokes a graph like Apex invoke would. And then you can just rotate the box around, the controller around, and it subdivides our box. So with that in mind, we can recreate the example I did before with the camera frustum, but with Apex to make it more actually nicer and not as much of a hack. So here it is. You have the same two controllers, which are those two like colorful arrows. And I can bring in, I can translate the arrows to like set the min and max depth of my frustum. And in this case, I even have this nifty padding control. So with this abstract control, I can move the mouse around, and it dilates or like erodes my box. So how does that work? It's also like very similar. I just have this grid of points, which is going to be my inputs, which is going to be those blue nodes. Then those green nodes basically do the same thing I did for the other HDA, which they make this skeleton. So the skeleton is what I'm going to use to place my controllers. And then the yellow nodes here on this right side is just going to be my Apex graph. And that basically, I'm going to show it to you later, just does what the HDA would do, which is just call the points outside of the frustum. Then I made these fancy controllers that I can then hook up, and they will show in the scene animate when I actually enter it. You can see them here, the two arrows and then the little star thing. So the graph basically just looks like this. We have our ingredients, which basically I just promoted the controllers to be there, and then I give it the shape and the skeleton. So the shape is our points, and the skeleton is the skeleton. And then from the skeleton, I get the positions of the points to actually... so these are the controllers, right? And they're driven by the position of the skeleton, so I can make sure that they're where the actual frustum would be. Then that just gets plugged into this volume bound, which creates the volume for the camera, and then everything that's outside of that just get blasted by this sub-blast, and then you become famous, and you have to become a sheep herder because the fame is too much for you to handle. Cool. More examples, because I know you want them. We have this Stairmaster 3000, which basically just builds a staircase, and you can like bring it up, and then you can rotate it, make a super nice Harry Potter spiral staircase. And the way that works is also fairly similar. We just have the one control, which is this, the gizmo is dragging up and down and like rotating. And then we just plug that into the copy transform sub. If you know what it is, you can just make copies of something. To make sure it stacks properly, we use the bounding box of the input geometry, and then the controller actually dictates how much it rotates, and as I bring it up, it dictates how many copies I want. In 20.5, we started this clip 2.0. We made this update to it. So I thought I'd do an example with this as well. So in this example, I just have a bunch of clip planes. They just run the clip 2.0, but as you see, as I'm moving those controllers around, I can slice Flippy as much as I want, and pretty cool. So now you're wondering what if I need more than one controller? What if I need a bunch of them? And that needs to be procedural. That needs to be based on what the input is. And that's what components are. And that's what we ship for like the KineFX workflow, where you would have a skeleton and you need FK on a bunch of joints, but your skeleton's not always going to be the same, right? So in this example, for example, we have this this should be FK actually. So in this FK transform actually takes in where your skeleton is, and it will create a controller, this transform object, for each joint. So if your input has 1 point, you get 1 controller. But if your input has like 100 joints, then you'll get 100 controller, and you could keep everything procedural when you're making the graph. So I decided to look at that and make something completely custom, because you can create all the components you want just the same way. So here is just a component that basically, for each face, it creates 2 controls, and it creates extrusion controls. So this guy controls the insets, then I can extrude the face, rotate it, and as I scale the gizmo, it actually subdivides the geometry further. So the cool thing here is that if I now change my input to a sphere instead, and I run the same graph on it, well, I get all those controllers rebuilt because I have many more faces. So I get the entire thing is now procedural, and I can create controllers on the fly. So I don't think this is super visible, but basically you have a box or a sphere, and then it gets fed into this pack folder, and then I just add my custom component, which is going to be the graph that I'm going to show you in a second. And then this guy is the actual scene animate, which runs our graph, generates our controls. So in this first image, you can see the graph that is the component. So that's the poly extrude thing that basically generates the graph that's going to be used by the scene animate. So this second graph is now the graph that was generated for the cube. But as you can see, the graph generated for the sphere down here has way more controllers because it has way more faces. So here's an overlook of what the component actually looks like. So at the start here, if I pause it, you can see those 2 nodes are basically boilerplate for making components. That's usually what you need to get the graph that's coming in. And then here we just get our stuff and create our poly extrude sub, which is basically, to do this, we just need the 1 poly extrude sub. But what we want is to actually add custom attributes to each of our faces. And that's what's going to drive how much we extrude the face by, how much we rotate it, how many subdivisions, and how much you inset the face. Because poly extrude supports having attributes on all your primitives to set how much you want to extrude it. So after we have this poly extrude, we just go into basically getting the, so this yellow node actually has a bunch of nodes inside, but what it does is it takes our geometry, and for each face, it will create a point and a transform, so we can actually stick our controllers onto those points. So then we take all of those points, and basically those will then set attributes on our faces. So as you see here, we get our points, and then this black node creates our transform object, which is the gizmo that you can drag around in the viewport, right? Then once we have that transform object, we can create the abstract control, which is the one you drag around like in a circular kind of fashion, which drives the inset of your face. And then once we have that, we can then create a bunch of set prim attrib nodes that will basically set the primitive attributes that we would need for the extrusion to work the way we intend it to. Because basically what the controllers do is they set a value for those attributes, and then that gets read in by the poly extrude, and that will then extrude the box the way you want to according to the controllers. And then there's a bit of cleanup and sorting at the end there. And you can see here, basically generates this graph. So this is the graph for the box. All of these are transform objects, which is the controller that you drag around. And then all of these are abstract controls, which is the circular gizmo that you move your mouse into and sets values. All of that then gets, I do some processing on there to feed like somewhat regular values into those set prim attributes. For example, like how many subdivisions you do has to be an integer, right? So what comes out of your gizmo is going to be a float. So you want to do some conversions there. And then at the end, you can see here, it just has the poly extrude, which does all the heavy lifting. We just have to give it the right data. And then this is pretty much going to be it. There's just this one last slide that I think everyone needs to see. Don't use curvy wires, please. They're awful. And you should use straight wires, because they're so much better and so much cleaner. Like, this is a giant mess. Oh, wait, before I forget, a lot of these examples are going to be on the content library sometime in the future. So if something felt, I mean, we're going to have the Q&A now, but if something felt like it was hard to understand, hopefully those examples will be helpful in that way. But yeah, that's it.
Cool stuff. Any questions?
Hi, thanks for the talk. Pretty cool. So the poly extrude example that you showed, it looks like it's quite a number of nodes involved in the setup. How intuitive or easy was it to set the whole thing up?
If you like scripting, I think it's much easier now because you can use Apex script. I made that example back in the days, like just after Houdini 20 came out. And at that point, I still wasn't at SideFX, and I had to like figure it out by myself. And like, yeah, some parts were like sort of tricky, but I think it's fairly, if you understand how Houdini works, it's like it's not a huge jump to go from regular like node networks to like the Apex network.
All right, thanks.
Anyone else?
Thanks for the presentation. Can this be easily integrated inside an HDA?
No. Well, the problem is that so the what drives all those controls and stuff is that viewer state, that Apex animate state, that lives within Houdini. So if you were to make like this in Unreal, you wouldn't have that interactive control that you get from the Apex animate. So you can definitely have an HDA inside of Unreal or any other package that uses Apex under the hood for sure, but you won't get that viewport interaction.
Okay, but inside Houdini, it's possible, or?
Yeah, totally.
Okay, and can we make custom viewer states that interact with the scene animate?
I'm sorry, what? Custom viewer state that what?
Interact with the scene animate, scene, I don't remember the name of the last node.
Yeah, so the Apex animate has that custom viewer state that I'm using for all of these examples. So because what it does is it takes your Apex graph and then generates controls for the controls you've created, and then just runs the graph. Are you wondering if you can extend the animate state?
Yes, like with the viewer state, trace ray, and all the cool thing.
We have plans to make it so that you can use custom tools within the animate state, if that's what you're asking.
Okay.
And by the way, that shout out to Mattistella in the bottom right. I think most people know Mattistella, but he's the architect or the author of CG Wiki, which is a huge resource for anybody learning or using Houdini.
He also had a Apex talk like at EPC.
Yeah.
So go watch that.
It's not available yet, but it will be.
When it's out.
I just want to say you're both wrong about curvy.
Oh, I know it's an unpopular opinion.
Kidding.
Kai loves curves.
You know.
Any other questions? Cool, Tom. Great talk. Thanks.
My pleasure.